Hello everybody and welcome back to Advanced Maths. Today we're going to be looking at some grade 7 to 9 exam questions on trigonometry. Before we begin, you need to make sure you know all of trigonometry really well. You need to know Pythagoras, SOHCAHTOA, sine rule, cosine rule, and the area of a triangle using sine perfectly. You need to be able to carry out all those methods without a hitch. If you're not really confident in all those, you need to revise my trigonometry playlist before we continue. But if you are happy, let's continue with our exam style questions. So here we are, we're going to find the size of the angle marked X. Okay, and we'll start with the triangle on the left because we already know two sides of that triangle and it's really easy to find the third using Pythagoras. So you're going to use Pythagoras. A squared plus b squared equals c squared. C is 10 and b is 7. And we're going to rearrange that, and we go to square root, and we get a is the square root of 10 squared minus 7 squared, which is the square root of 51. And so we can say that this side here is the square root of 51. And that's going to help us because now we can do SOHCAHTOA and sine to find the missing angle. Okay, so the opposite is square root of 51, and the height is 12. We can substitute those numbers in, and we take the inverse sine of both sides. Remember, you take inverse sine if we're finding an angle. And if you type that into your calculator, you should get 36.5 degrees. And that is the final answer. Okay, let's look at example 2 now. So here we've got triangle ABC. And one side is labelled 2x plus 1. Another side is 2x minus 1. And the opposite side is 2 root 7. Let's see if you can do this. So I would recommend to pause this video now and try this yourself and see how well you do. Because in a few moments I'm going to show you how to do this. Are you ready? Let's have a look. So we're going to use cosine rule here because we only know one angle and we don't want to find any other angles. So we wouldn't use sine rule here because sine rule will be if you're interested in two different angles. But here we're only interested in three sides and one angle. Okay, so we can label those sides here. I can see A is in green, B is in blue, and C is in red. And we can start substituting those numbers in, those terms in because they're not numbers. So A goes there in brackets, B goes there like that, and C goes like that. And then finally the angle, cos A, goes in the cosine rule like that. That is just substituting those terms into the cosine rule. Okay. Now we're going to try and simplify this. And this is quite a lot of algebra, so I'm going to try and simplify it step by step. Let's start with the 2 root 7 squared. Well, actually, sorry. Let's start with the cos 60. Cos 60 on your calculator is a half. So immediately replace the cos 60 with 1/2. Now we've got the 2 and the half here. The 2 times 2x minus 1 times 2x plus 1 times a half. And that 2 times a half disappears because 2 times a half is 1. And when you times it by 1, you can just get rid of it. Like that. So the 2 times a half disappeared. Now we'll do the 2 root 7 squared. We'll do it this time. 2 root 7 squared on your calculator, make sure you're using brackets, is 28. And that's because 2 root 7 squared is 2 squared times root 7 squared, which is 4 times 7, which is 28. Now we're going to expand the 2x minus 1 squared, and that's a double bracket, and it becomes 4x squared minus 4x plus 1. Now we'll expand the 2x plus 1 squared bracket, and that's 4x squared plus 4x plus 1. And finally, those two brackets multiplied on the end, we'll expand those, and we'll get 4x squared minus 1. But remember, we are subtracting these two. So we have to remember the double negative here, or the double bracket. So we're subtracting the 4x squared, and we're subtracting the minus 1. Because we're subtracting minus 1, that means add 1. So that's a bit, you have to be careful with your algebra there. Okay, so that algebra there we just did was quite tricky, but I showed you each individual step to simplify it. Try and do that yourself, and try to expand all those brackets yourselves, and keep track of it all. Take your time while you're doing that because it can be a bit overwhelming, but you can get there. Now we're going to cancel out some like terms. So the 4x squared and the minus 4x squared disappear. They can disappear. Now you've got minus 4x plus 4x, they can disappear. And you've got 1 plus 1 plus 1, which is 3. And so all of that simplifies to 28 equals 4x squared plus 3. And we need to just solve that equation now. We'll subtract 3 from both sides and we get 25 equals 4x squared. Divide by 4, and 25 over 4 equals x squared. And then we'll square root both sides. And that's equal to x. And the square root of 25 over 4 is 5 over 2 centimeters. And so x must be 5 over 2 centimeters, or 2.5 if you prefer. And that is the final answer. Okay, so that was really algebra heavy, but we managed to get there if we keep track of our algebra very carefully and then simplify and solve the equation. Okay, let's look at our final example now. So the diagram shows a regular pentagon inside a circle, center O. The points A and B lie in the circle, such that AB is the side of the pentagon. OA is 7 centimeters, and TA is a tangent of the circle, and OBT is a straight line. Calculate the area of the shaded triangle. I've shaded it in blue here for you to see. Okay, so we can start by realizing that this regular pentagon here creates 5 triangles. And the angle inside those 5 triangles, well, we can work that out by doing 360 divided by 5 to get that each angle is 72 degrees. So that red angle there is 72 degrees. Now we can use tan to find the opposite side of the triangle, and we can use that will be useful because that length is important. Okay, so the tan of theta is opposite of adjacent, so adjacent times tan of theta is the opposite, and we substitute those in. 7 is the adjacent, and the angle is 72. We type that into a calculator and we get the opposite is 21.5437 centimeters, so you can label that 21.5437. This helps us work out the area of that full triangle there. So we substitute those numbers in, the base times the height divided by 2. And again, we type that into our calculator, we get 75.4 centimeters squared. The area of this yellow triangle is that 75.4 centimeters squared. Let's make a note of that there. Now, we are also going to work out the area of this pink triangle here. You might see where I'm going with this. And so we're going to do realize that these two sides are the same because they're both radiuses of the triangle. And we get that area equals half AB sine C. We substitute those numbers in, 7 and 7, and the angle is 72, the C is 72. Type that into a calculator once more time, and we get the area is 23.3 centimeters squared. So that pink triangle is 23.3 centimeters squared. And you might notice that to find the blue triangle, you combine these two, you can subtract it. So the yellow minus the pink areas will give you the blue areas. And so we get this, and we get the area 75.4 minus 23.3. You can subtract that on your calculator, and you should get the area is 52.1 centimeters squared. And that is the final answer. Okay, so you've seen all 3 examples from today's video. I would recommend re-watching this video a few times and pausing it before each example to see if you can do those examples again yourselves. You might also want to make notes and copy these examples down into your books. But if you're ready, I've got some practice questions for you to try here. Question 1, it says a parallelogram has side lengths of 9 and 5 centimeters. One of the angles is 124 degrees. Calculate the length of the 2 diagonals. Now those 2 sentences there describe a parallelogram, and it would be a good idea if you could draw a sketch of that parallelogram to help you. Draw it quite big so you have plenty of room to work with. Also, I've got question 2, calculate the value of x. You've got enough information there to find the value of x. Pause the video now and try this yourself. Let's see how well you do. But if you're ready, I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the comments below. Thanks for watching this week's video from Advanced Maths. We're covering more videos every week, so remember to like and subscribe so you don't miss any future videos. We also have our website, advancedmaths.com, which you're welcome to check out for more revision resources. Thanks for watching and good luck in your exams.